For this video, we're going to be talking about something from Chapter 4 called the Remainder Theorem. So basically what this tells us is if we have a function, so something like this from this IXL that I'm using as an example, uh, using synthetic division, so that's something we've already talked about, whatever we get as our remainder, so the number at the end, is going to be the same as if we were to plug this number into the function itself. So we can use a type of division that we already know as a potentially quicker way of just plugging in to a function. So what we would do with this is, in this instance, it says f of 3. So we would use 3 as our number in the corner up here. So remember when we had synthetic division, we have kind of like a template that we set up each time. Across the top, I'm going to use the coefficients here. So a 7, a negative 29, and a 28. 7, negative 29, and a 28. So as a refresher for synthetic division, the first number is going to drop down because it has nothing to combine with. So I'm still going to have a 7 down here. 3 times 7 is 21. That goes underneath the next column. Anytime I have a new number up top, they're going to combine or add together. So negative 29 and 21 is going to give me negative 8. 3 times negative 8 would give me a negative 24. And 28 minus 24 would give me a 4. So what that tells me is in this box I should get a 4 here, which would be the same thing as if I plugged in 7 times 3 squared minus 29 times 3 plus 28. Awesome. So the reason we would do that, for some of these, as we have smaller polynomials to start with, plugging in wouldn't be too bad. However, once they get more complicated, it's going to take longer and longer, whereas if you're good at synthetic division, that would likely be quicker than solving this out by hand. So let's show one more, and then after that I'm guessing that we're going to be pretty good as long as we're okay with synthetic division. And remember, if you're not for any reason, we do have a video explaining how to divide polynomials too, so we could go back and watch that if necessary. So for this template in the box in the corner, it wants us to solve what would we get when the value of this function is 4. So I would plug in 4 up top. I would set up my template. Across the top I'm going to have a 1, a negative 3, a negative 10. So I'm just using the coefficients again. A 22, and an 8. Remember, whatever the last number is always goes on the other side. So the first number drops down, that's a 1. 4 times 1 is 4. Anytime I get something new up top, they combine, so that's going to give me a 1. 4 times 1 is 4 again. Negative 10 plus 4 is negative 6. When I multiply 4 and negative 6, that gives me negative 24. When these add, I'm going to get negative 2. And 4 times negative 2 is negative 8, which means these last two things are going to cancel out to 0. So that tells me that a 0 is going to go here. This also touches on something called the Factor Theorem. So what we're doing so far is called the Remainder Theorem. The Factor Theorem basically is using the same thing, but anytime we get a 0 as our remainder, it tells me that that thing is a factor. So if this is the number in the corner here, x minus 4, which would give us that, is a factor of the original polynomial, meaning it's something that could divide out without leaving a remainder, which makes sense because we got a 0 there. So let's submit this and make sure we're on the right track, and if so, we can kind of wrap up here. Awesome. So a lot of the process here is the same. There's not too much variation. So just a quick recap in case you're not doing an IXL itself. Synthetic division is this process with this template. We're plugging in whatever is in parentheses at the end and getting its remainder for the remainder theorem. That's the same thing as if I would take this number and plug it in for each variable. When they get to be longer polynomials like this, it'll probably be quicker, at least if you know synthetic division well. And then something called the factor theorem is if we get a 0 left over here, it tells me whatever would make this number. So in this instance, if this was a 4, the thing we were dividing by must be an x minus 4. That thing has to be a factor. So we'll wrap up there. Hopefully this helps, and we'll see you guys for the next video. See ya.